Alright, so here's the setup. We've got our candle on this end, that'll be our object. It's going through this convex or converging lens, and then it's going to hit our little note card on the end. This is our projector card. So our candle or our object is going to start at 5 centimeters, and it's going to go through the lens at 25, which means the object distance is 20, right? You just find the difference between the two. So for number 1, the object distance, DO, in centimeters is 20. So then our light from the object is passing through the lens, and it's going to catch the light over here on the projector sheet, or the projector card. You can see it's not quite a crisp image yet, so we're going to move the card a little bit closer. Yeah, closer. We're going to move it closer so that it gets a sharper image. You can see as I bend it forward like this that it needs to go forward to get sharper. So we'll move that. A little more. There, that looks pretty good. So yeah, you can see that the image is a lot sharper. So this is where all the light is being focused. This is at 90, we'll call it 91 because it's leaning forward a little bit. So 91 centimeters. So you'll have to do 25, which is where the lens is, and 91. Find the difference between those, and that gives you the image distance. You can see the image is a lot bigger. I had to move the card up so that you can even see the whole image. So the little candle was made way bigger as it came through the lens because of how far away it is. So now we're going to move to number 2. You can show your work here in just a second, or you can pause the video and show your work now. It's up to you. But we'll move the lens for part 2, or number 2, I guess, of this part. And so candle still at 5 centimeters. Our lens is now at 40. And so we'll have to move our projector card so that we can see the clear image. So it's not quite clear yet. We'll keep moving it, keep moving it. It's kind of stuck. Come on. There we go. And yeah, now we can see a really clear image of the candle, the flame and the candle in its holder. So there's the candle, and there is the image. This is what projectors do. They just take an image and they project it onto a screen. I darkened it a little bit so hopefully you can see the detail and how it's really clear. And this is at 67.5 centimeters. So remember, you have to find the distance from 35 or 40 to 67 or 60. Yeah, 67.5. That's the image distance, and the object distance is going to be the 5 minus the 40, or sorry, the 40 minus the 5. You're just finding the difference. As far as the size of the image. The image is actually a little bit smaller than the object. There you go, you can see that. So the image is a little bit smaller, still inverted. And now we're going to do number 3. We'll do 52 centimeters. And our projector needs to move back a little bit. Oh, it's stuck again. There we go. So you can see our image is now pretty clear, and it's a lot smaller than the first one was. So our lens is at 52, our image is at 74.5, so to find the image distance you would subtract those, and our object is still at 5. So 52 minus 5 gives you the object distance, and then 74.5 minus 52 gives you the image distance. Okay, so for the mirror, we've got our mirror here. Here's the top-down view. This is what you'll be seeing on your paper. I've got a laser to kind of show you what each person can see. I can bounce a laser off, and that's kind of like the line of sight. So person A can see person C because the laser can touch. They can also see person E, but if I try to go further, the light never actually hits person G, which means person A cannot see person G. And so from person C, the light can hit person A, which means person C can see person A. They can also see themselves, but they can't see person E or G because the light is not bouncing onto them. Person E can see person A because the light can reach person A, but we can't see person C from E. And then person G, the light just barely doesn't touch A, which means person G can't see anybody.